So, Ganesh, tell me about yourself.
Yes, sir. First of all, good morning, sir. My name is 𝐂𝐤𝐚𝐴. I am from Puliyandula, YSR Kadapa district, Andhra Pradesh, and I have completed my BTech from JNTU College of Engineering, Anantapur. And coming to my family background, my father name is 𝐂𝐤𝐚𝐿. He is a farmer, and my mother name is Rajeshwari. She is an homemaker. And during my academic journey, I had an opportunity to do my final year project at IIT Hyderabad, where I had worked on the optimization of mycelium biomass on the submerged cultivation of Pleurotus austriatus mushroom. And I have also did my internship at Iranian Corporation of India Limited, Tummalapalli plant. And during my internship, I had an I had gained an valuable experience over there. And apart from that, recently I have got an All India rank 144 in GATE 2025, which shows my strong technical foundation and dedication towards chemical engineering. That's all.
Okay. Tell me the topic of your internship.
Sir, internship, sir. Basically, we have gone through entire brief overview of uranium extraction from mines to final product, that is sodium diuranate, sir.
Okay, tell me about something more.
Yes, sir. Here the plant is mainly works on the extraction of uranium from the ore to final product, that is sodium diuranate. And first the ore is extracted from the mines that is nearby to the plant, and that ore is sent to the crushing units for the size reduction. And after the size reduction, the main process starts, that is alkaline leaching taking place over there. And in the alkaline leaching, by the action of solvents, that is sodium hydroxide and sodium carbonate, that whatever uranium that is present in the solid form, that can be converted into liquid form in the leaching process. And this liquid further sent to the precipitation tanks, and in between there is some separation separating techniques, like some clarifier is there, like some dissolved or some suspended solid particles present in the particular liquid, that can be removed with the help of clarifier, and then it is sent to the rotatory drum filter, where in case if some solid materials or solid particles that is present in the liquid, that can also be separated it out there. And further this liquid, pure liquid, this is sent to the precipitation tanks, and in the precipitation sodium hydroxide we are adding over there. And by the action of sodium hydroxide, that uranium that will be precipitated in the form of yellow color at the bottom of the tanks, and this will further send to the industrial thickener, where we will add some flocculant, that is flocculant. And by the action of flocculant, these uranium particles will become denser and denser, and settle down there. And this bottom product we will take it out, and this will send to the spray dryer. And in the spray dryer, the moisture content.
All right, got it.
Yes.
Okay. So tell me about some favorite subjects in which you are a student.
Yes, sir. Heat transfer, CRE, fluid mechanics, mass transfer, and thermodynamics.
Okay, so Ganesh,
Yes, sir.
is it fine if I call you Ganesh?
Yeah, yes.
Ganeshwar.
Yes, sir. Yes.
Okay. So you said heat, CRE, FM, mass and thermal. So you are preparing for BARC and NPCIL both, correct?
Yes, sir.
Okay. So shall we start from thermodynamics?
I'm not quite bit confident in thermodynamics as of heat, sir.
Then why you mention thermodynamics here?
Yes, sir. That's why I have kept it as last preference.
Then keep it just said 4 subjects. If they
Okay.
ask you for the fifth, then you can mention.
Okay, sir.
Okay. Anyways.
Okay.
So Let's talk about a little bit of both. So, what is the difference in the role of BARC and role of NPCIL in the country?
Yes, sir. In BARC, basically, BARC is basically do the research works and like it will take care of radiational safety concerns and all, and it will go through the mainly it will focuses on the research works and all, and whereas NPCIL it is mainly focuses on the power generation.
So, who worked for the development of atom bombs, nuclear bombs, nuclear weapons?
Nuclear weapons, nuclear scientists, I think.
Which organization?
Nuclear, DRDO and some BARC.
DRDO has nothing to do with the nuclear things. Between BARC and NPCIL, I'm asking.
Between BARC and NPCIL, mainly I think BARC itself, sir.
Okay. Do you have the idea in which year in first atom bomb was developed in the country?
No, sir.
Well, just asking. Any idea?
No, sir. No idea about
Then
it.
fine, it's okay. Do you follow the? What is your favorite sports?
Cricket, sir.
Cricket. So, which team you are supporting currently in IPL?
Chennai Super Kings.
But they are out.
Yes, sir.
What was their position in the points table?
No, sir. My favorite team is that, but currently I am not quite bit aware of that. So
you are not watching IPL?
Yes, sir. Currently I am not watching IPL.
Why? Because of BARC and NPCIL preparation.
Yes, sir.
Okay, wonderful. So your first two favorite subjects are heat and CRE.
Yes,
Okay.
sir.
Okay. So Manish sir, please you do start.
ठीक है. All right. So now,
yes.
are you able to listen?
Yes, sir. Yeah. It's
So
audible.
tell me about the modes of the heat transfer.
Yes, sir. There are three modes of heat transfer. One is conduction, convection, radiation. In the conduction, heat transfer takes place due to the particles interaction, and driving force here is temperature gradient. And particle interaction in the sense particles are not allowed to leave its mean position, and they exchange heat between them through vibrations. And whereas in convection, heat transfer takes place between due to the particle interaction, but here particles are allowed to leave its mean position, and it can move here and there and all. And the main driving force here is temperature difference. And whereas in radiation, the heat transfer mainly takes place in the form of electromagnetic waves that can travel at a speed of light, that is 3 into 10 to the power of 8 meter per second. And for the radiation heat transfer for the happening of radiation heat transfer, there is no need any physical contact or medium existence, and it can be takes place in vacuums also. And in the radiation, heat emits from lower temperature body to higher temperature body. Whereas in conduction convection, it cannot happen. Only heat is transferred from high temperature place to low temperature place. Whereas in radiation, heat will transfer from lower temperature body to higher temperature body. The only need is that the body should be present at greater than absolute 0 Kelvin temperature. Yes.
Okay, very good. So Ganeshwar, you are giving the interview, right?
Yes, sir.
In the desktop, laptop, or phone?
Laptop itself.
Okay. So you are feeling some energy transferring from your system.
Yes, sir.
To you.
Yes, sir.
So which mode you have observed in this phenomenon?
Okay, so in this phenomena, the first one is convection, obviously, and some radiation will be also there, but the magnitude of radiation will be quite lower than convection.
How?
Yes, sir. Here in okay, so, here radiation to for the radiation to be happen.
Because of in the radiation you are seeing the emissive power
Yes, sir.
as T2 power 4.
Yes, sir. Yes, sir. It is depending on temperature. Here, temperature will be low.
So
I mean,
temperature
almost.
in convection and radiation are same.
Sorry, sir.
This is your desktop or laptop.
Yes, sir.
Temperature is remains the same of the body in both
Yes.
case, convection as well as radiation, right?
Yes, sir.
So I am asking to you, which mode, in which mode you are getting the heat or receiving the heat more, with the help of convection or radiation?
Mainly with the help of convection only, sir. And radiation to travel, there is some distance between laptop and me. So in between the radiation heat transfer, magnitude.
Which one will be more? Which one will be more? Radiation
Convection. Convection will be more.
Yes, this is my question. Why?
Yes, sir. In the convection, heat transfer takes place due to the temperature difference, like temperature
let's
of
see.
lab.
Try to explain with the help of mathematics magnitude of the convection. Magnitude of convection is Q equal to HA delta T, right?
Yes, sir.
So you took the some heat transfer coefficient.
Yes,
Okay.
sir.
Area
Yes, sir.
for radiation and convection are constant, right? And delta T is the surface body of the system, and T surrounding is fixed in both cases.
Yes, sir. Yes, sir.
And TS is fixed in both cases.
Yes, sir.
Right. So, and QY radiation, you explain to me.
1 second, sir. Yes, sir. Yes, because in the radiation, we have temperature in the power of 4, temperature in the power of 4, sir. That is drying force for that. And in case of conduction, the temperature is just temperature difference between surrounding and system, sir. For this convection, there is only heat transfer due to temperature difference, whereas in radiation heat transfer takes place due to temperature to the power of 4. And if we make it temperature to the power of 4, we will get something value, like if we take ambient temperature to be 25 degrees centigrade, 27 degrees centigrade, and it should be 300. I mean, converting to absolute scale, it should be 300, and 300 to the power of 4, it will give some 10 to the power of 7 or 10 to the power of 8 ranges. And if here we are also multiplying with Stephen-Boltzmann constant, and this is 5.67 into 10 to the power of -8, and this 10 to the power of +8 that comes from temperature difference, and 10 to the power of -8 that comes from this Stephen-Boltzmann constant. This will both get cancelled out, and this term makes the radiation heat transfer magnitude of radiation heat transfers to be small than the convection.
So in which case you are getting the more value of heat transfer, in the case of radiation or convection?
In the case of convection,
actually something internet issue I think you are facing. थोड़ा सा इंटरनेट इशू है क्या, देखो तो?
No, sir. I'm getting clear.
No,
Now is it
you are
okay, sir?
getting yeah. So in yes, so you are calculating the rate of heat transfer with the help of convection, delta T, right?
Yes,
So
sir.
delta T here, Ts minus T surrounding, right?
Yes,
So
sir.
you are assuming the Ts temperature, how much?
Surrounding temperature 27, sir.
27, right? Okay. So Ts minus 27. This is the main driving force, right?
Yes, sir.
Or here T2 power 4 minus Ts to power T infinity to power 4, right? So which driving force is more, with the help of radiation or convection?
Mm,
You just think about this.
Yes. So, for the instance, let's assume this temperature that to be like 30 or 35. Like, if we assume this as 30 degrees centigrade, I mean 30 degrees centigrade, it is like 303 to the power of 4, 303 Kelvin to the power of 4 minus 300 to the power of 4. This is the driving
You
force.
can calculate the driving force. You can calculate it.
So, can I use the calculator, sir?
Yeah, sure.
So, it is more in case of radiation, sir, driving force.
So earlier you were saying the convection, right?
Yes, sir.
So this is contradictory point, right?
Yes.
Okay.
Yes, sir.
So now, what is your conclusion after the calculation?
Yes, sir. Here, driving force for the convection is for the same temperature. For the same temperatures, driving force for the convection is less than the driving force for the radiation. But here, sir, if I calculate this temperature difference to the power of 4, this difference, I'll get around 3.29 into 10 to the power of 8, sir. But area same.
Yes.
One second, sir. One second. Area will be same and emissivity is less than 1 or yes, sir. Here temperature difference to the power of 4 in the case of radiation, that I'm getting around 3.29 into 10 to the power of 8, sir. But here one term comes in the radiation, that is Stephen-Boltzmann constant. If we multiply with 5.67, that is Stephen-Boltzmann constant value, 5.67 into 10 to the power of minus 8. This power terms like 10 to the power of 8 and 10 to the power of minus 8 get cancelled out, and this and this only now this only depends on emissivity. Emissivity will be between 0 to and 1, and this is some, let's assume for the case some fractional value 0.7 and yes, 0.7, and if we multiply with this 3.29 and 5.67, that will come from Stephen-Boltzmann constant, and the emissivity 0.7, and area will be constant, and let's make it as a flux. Okay, so, can I calculate it, sir?
Yeah, you can calculate and take the yes, you can calculate the rate of heat transfer by the radiation and as well as by convection. Assume the heat transfer coefficient of the air. Okay, have you idea the in normal temperature air heat transfer coefficient? How much?
Heat transfer temperature of air.
No, heat transfer. What is the value of heat transfer coefficient at the room temperature?
I have here it is low, as quite smaller, but exactly value.
You should know na ki what is the heat transfer coefficient of the air and okay liquid. You know, so you have to get the idea. Okay, take okay. You can okay help from the Google. You can do the Google as well. No problem.
So it is between 5 to 250 watt per meter square Kelvin.
Yeah, 5 to
250 watt per meter square Kelvin.
yes, 5 to 15.
250 it is.
250.
No, yes, sir, but
so at room temperature you can took.
okay. For the instance, let take it is as 10.
Okay. 10. You can. Yeah.
Yes, sir. It is more in the case of convection only, sir. In case of radiation, I'm getting heat transfer flux to be 13.05 watt per meter square, whereas in the case of convection, it is 30 watt per meter square, sir.
30.
Yes, sir.
So again, earlier you are saying the radiation rate of heat transfer is more. Now your ultimately conclusion is convection.
Yes, sir. Convection, in the convection heat
So
transfer
you are
only, the
starting
heat
with
transfer.
convection and comes to the radiation, and final again you are saying
No,
that
sir.
convection.
No, sir. If we only look at in the case of drying forces, that is delta T, only basis on the drying force, ignoring ignoring this all
You
terms.
cannot ignore, ना? You cannot ignore.
Yes, sir. Yes, sir.
कोई आपसे पूछता है कि नेट रेट ऑफ हीट ट्रांसफर कितना हो रहा है, तो इग्नोर नहीं कर सकते हैं ना. ओनली ड्राइविंग फोर्स इज नॉट फैक्टर, राइट?
Yes, sir.
Driving force can enhance the rate of heat transfer or decrease the rate of heat transfer, right?
Yes, sir.
This is the role of the driving force.
Yes, sir.
Right?
Yes.
All right. So ultimately conclusion you can say again.
Yes, sir. In case of convection, heat transfer. In case of convection, heat transfer is more than the radiation.
Yes. Explain why this is happening.
Yes, sir. By considering all the factors, like in case of convection, heat transfer coefficient and temperature difference, the heat transfer rate will be rate or for the same area, flux will be more. And in case of radiation, we are considering with some that Stephen Boltzmann constant and emissivity we need to consider. And then obviously area we need to consider. For the same area, we can make it as a flux, and mainly the drying force, that is temperature to the power of 4 of S to the surrounding. And
Good. Very good. Okay. All right, sir.
Yes, sir.
Ankush, sir. Yes, sir. You can ask.
Okay, so Ganesh,
yes.
have you done any study about the NPCIL and the processes involved there?
Yes, sir. I have a basic idea about it, sir.
So, do you know anything about the reactors they use?
Yes, sir. Mostly they are using pressurized heavy water reactors other than the boiling water reactors.
So, what is the main difference between these two, which you mentioned?
Yes, sir. In pressurized heavy water reactor, we will use as moderator. We will use as the moderator of D2O, that is deuterium dioxide. That is what heavy water, sir. And it is a deuterium. Deuterium in the sense that is heavier isotope of hydrogen, sir, and which acts as a moderator as well as coolant for the reactor system, sir. In case of heavy water, pressurized heavy water reactors, sir. While in case of boiling water reactors, we will use normal water as a coolant, and also this is in the form of H2O, and it will also act as a moderator in some cases. Yes.
Okay, so if I talk about the nuclear power plants, like
Yes,
where electricity is produced, you said and earlier also NPCIL is in power generation.
Yes, sir.
Correct. So, out of these two, which reactor is more suitable? Or matlab, we should say, from the safety point of view, which is better?
From the safety point of view, pressurized heavy water reactor will be better, sir, other than this boiling water reactor.
Why?
Yes, sir. Yes, sir. In pressurized heavy water reactor, we are using D2O, that is heavy water, and which acts as a both coolant and moderator itself. And there is no direct contact between, and we are generating steam with this circulation of heavy water in the some heat exchanging coils, and further we will sending some external water into it, and there is no direct contact between this heavy water this heavy water and whatever the water we are using for the steam generation. So the radiation effects will be less in this case. Whereas in boiling water reactor, there will be direct contact between these two, and steam is directly generated inside the reactor, and this will
Yes.
this will make more radiational, further streams to be more radiationally active or more radiational effects. And yes, and we can ignore. So in this, yes, we will get less radiation effects in the case of pressurized heavy water reactor. More radiation effects in case of boiling water reactor.
Okay. So here you said all these things. So I just want to know, do you have any idea about the nuclear hydrogen?
Nuclear hydrogen, sir.
Yeah, hydrogen production in nuclear reactors or NPCIL or something like this. Just simply say yes or no.
No, sir, no idea about it.
Okay, no issues. So if I have to apply the fluid mechanics principles in these reactors, so which principle do you think we can use? Just name the principles which you think that yes, we can use in this designing which you just mentioned. Let's consider the pressurized heavy water reactor, as you said. That reactor, D2O, boiler, heat exchangers, steam generation, all these things are there. So I just want to know which fluid mechanics principle we can use.
I mean, like what concerns, sir? Like heavy water concern or this?
In all these things, list of those principles. Like the idea is I want to design all this, so I should have a knowledge of fluid mechanics. So which part of fluid mechanics I should know before doing all this? So that's what I want to know.
Yes, firstly, we have been aware of fluid dynamics, how the fluid is flowing inside the pipes and all.
So don't go in the chapter and name, just the name of the principles, like Bernoulli principle, Reynolds number, flow regimes, schedule number, so many things are there. So
Yes.
from fluid mechanics, which topics or headings are coming in your mind? Do you think that yes, they will be involved in these things?
Yes, firstly, we should aware of Reynolds number that will defines the from this we can conclude that whether
Just
flow
tell me the name,
yes,
not
sir,
the
okay.
use.
Yes, Reynolds number, and if the flow is a streamline body, streamline flow, and then fluid is incompressible, and it is if it is steady flow and as well as viscous fluid, then
These are the assumptions you are saying. I'm talking about the principles, laws, equations, formulas.
Yes, 1 second, sir.
You said your fluid mechanics as a third subject.
Yes,
So
sir.
you must have studied Bernoulli principles,
Yes, sir.
Euler's equations of motions,
Yes, sir.
Darcy equations, Darcy-Weisbach equations, friction factors, pipe flow and losses,
Yes.
boundary layer theories, drag forces, lift forces.
Yes, sir.
Correct? Newton's
sir.
second law of motion, third law of motion, first law of motion, inertia, moments of inertia. So many things you must have studied in fluid mechanics.
Yes, sir.
So I'm just asking those things, not the assumptions. What will I do with that? I'm not asking you to design. I'm just asking the name of those topics, which you
Yes,
think
sir.
will be helpful in the study of all these things.
Yes, sir. Basically, here fluid is normally here flowing in the pipes itself. So we should consider the Bernoulli's principle. That is not pure Bernoulli's, modified Bernoulli's, which accounts head loss as well, and yes, sir, which accounts head loss as well. And we also
I'm not asking the application, just name.
yes, sir, Bernoulli's principle and Darcy-Weisbach equations we can use, and return losses we have to consider.
Sorry?
losses due to return bends, sudden expansion, sudden contraction.
Okay. Only these three and Reynolds number 4. These 4 topics are coming in your mind.
Yes, sir. We should
Okay,
also.
let's talk about your first topic, CRE. So in CRE, do you know about the CSTR?
Yes, sir.
Okay. So if I want to design the CSTR,
Yes, sir.
how can we do that? Suppose I have a CSTR,
Yes, sir.
let's say wrote down.
Yes, sir.
Second order reaction is there.
Yes, sir.
Rate constant K is suppose 0.1 liter per mole per hour.
Yes, sir.
Molar flow rate of A in the feed is
Yes, sir.
100 moles per hour.
Yes, sir.
Initial concentration of A is let's say 20 mole per liter,
Yes, sir.
and desired conversion is 80%. So
Yes.
tell me the volume of CSTR required
Yes, sir. One second,
first,
sir.
and then how can I calculate the length and diameter of the reactor?
Yes, sir. One second, sir. So volume of reactor comes out to be 2 liters, sir.
How much?
2 liters, sir.
2 liter.
Sorry, sir. I have mistaken once. 50 liters, sir. Sir,
Yes.
it comes out to be 50 liters, sir.
50 liter.
Yes, sir.
Okay. Now how can I calculate LND?
Yes, sir. Basically, CSTR is an cylinder, right, sir? Cylinder, right, sir? We have.
Don't tell me the value, just tell me the process steps.
Yes, sir. First, we need to fix the L by D ratio, sir. L by D
So
ratio.
we can fix it by our choice.
Yes, sir. It is.
Any ratio we can pick, like 9, 10, 99, anything.
No, sir, we can't go with that much value. L by D should be 1 to 3. 1 to 3. It would be better for mixing, sir. And if we increase the length, and we have to, if we increase the length, we have to increase the impellers in the reactor for the better mixing.
That's fine. But why the L by D ratio should be between 1 to 3?
So in between this ratio, mixing will be better itself, sir.
That's what I'm asking. Why?
That means motor will take less power consumption for this mixing, and there is no effort that had been on the motor.
Okay.
And it is easier to, in between this L by D ratio, it is easier to mix the streams whatever present in it. Then other, like if you go far from this L by D values, we have to increase. For suppose if L by D value increase, and length should be increased obviously, and as length increase, we have to increase the impeller. We have to add the more impellers to do the better mixing. So in order to avoid that, and we can achieve the mixing with only one impeller, we will prefer this value, sir. 1 to 3.
Okay. So what is Darcy-Weisbach equation?
Yes, sir. It is HF is equal to FL V square by 2GD. Here, capital F is the Darcy friction factor, and V is the velocity, that is velocity of fluid that is going inside the pipe, and L is the.
So can you tell me the Darcy-Weisbach equation in terms of volumetric flow rate?
Yes, sir. HF is equal to So can I write it?
Yeah, take your time.
Yes, sir. It is FLQ square into FL HF is equal to FLQ square divided by 12.1 into D. Here, for calculating 12.1, I have considered G as 9.8.
12.1 into D.
Yes, sir.
Nothing in power.
D to the power of 5, sir. Sorry.
That is the only difference now. That
Yes,
is the
sir.
main difference.
D to the power of 5. And here, for calculating this 12.5, I have considered
So
9.81.
can we use Darcy-Weisbach equation for laminar flows?
Yes, sir. It can be used for both laminar
So
and
what will be the
turbulent.
difference between the Hagen-Pauschel equation and Darcy-Weisbach equation in that case for flow through or circular pipes?
Yes, sir. One second, sir.
Both will give the same result now.
Both will give same results, sir.
That's it. What is the difference? Nothing.
Yes, sir.
Laminar flow regime, the only difference will be in the nature of equations.
Yes, sir. Here we will see.
But application and results will be same.
Yes, sir. Application and results will be same, but we will see viscosity term in the Hagen-Pauschel equation. Here, Darcy-Weisbach equation, we will see friction factor directly.
Yes, that's what you have to tell.
Yes, sir.
सब कुछ लास्ट में बता रहे हो पूरी कहानी मेन see you have the knowledge but in interviews especially in BARC and NPCIL try to think when they ask any question, think always why they are asking this question. Okay, then it will be easy for you to answer. Because if you can figure out what is the purpose they are asking you any question, then you will be able to hit the mark. You know that now it is very convenient to impress someone or convince someone if you can speak the same thing which they want to listen.
Yes.
So always when in interview, try to think if they are asking any question, so take a couple of seconds and think why they are asking this question and how I can answer. Okay, so that's why whenever they ask anything, take those 3-4 seconds pause and then speak. It will help you.
Okay.
Although you are doing this, but in this add one more thing, why they are asking any question.
Yes.
Okay, and most of the question you will be able to answer, such type of question you will be able to answer because you know all these type of things you have already done in gate preparation, especially solving the numericals.
Yes.
Okay, if you have done FM classes,
yes, sir.
So you know in FM, when we solve the numericals, we use Hagen-Pauschel equations, we use Darcy-Weisbach equation for laminar flow,
Yes,
depending on the data given.
Yes, sir. If data given in friction factor, we will use Darcy-Weisbach equation, or if in the form of viscosity, we will use Hagen-Pauschel equation.
Yes, that is the difference now.
Yes.
So first say this, and then you can add. So technically, as such, there is no difference. But if you want to know mathematically, then here viscosity comes, and here friction factor.
Yes.
Although viscosity and friction both are the same thing.
Yes, sir.
Okay. Now, what is catalytic poisoning?
Yes, sir. Catalytic poisoning in the sense there is some catalyst with us and some foreign particle that is not a part of reaction that comes with comes in contact with catalyst and react with the catalyst and makes an inert layer over the catalyst surface and which restricts the other our reactant for suppose our reactant to be react in the active sites.
To absorb.
Yes, sir, to absorb.
That's correct, but be careful. For reactants does not react. Reactants first absorb and then they react.
Yes, sir.
So because of the poisoning, they will not be able to absorb.
Absorb. Yes, sir. They will restrict.
So obviously reaction will not come in the picture.
Yes, sir.
Okay. Can you tell me any example of catalyst poisoning in nuclear reactors?
For the initiation of reaction, we are, I think we don't use the catalyst in the case of nuclear reactor.
What is our role of catalyst? Why we use catalyst?
Okay, so catalyst that participate in the reaction and that cannot be consumed or permanently altered, but increase the rate of reaction by following different pathways and reduce the activation energy required for the.
So can I say anything which helps improving the rate of reaction is kind of a catalyst? That is the basis of autocatalytic reaction as well, where products are considered as catalysts.
Catalyst as well.
So who said that catalyst has to be a separate quantity?
Yes, sir. Catalyst will be.
Anyways, chalo, leave it. What is a exothermic reaction?
In the exothermic reaction, mainly due to the reaction, heat will be released and enthalpy of exothermic reaction will be negative and negative.
What will be the change in Gibbs energy? Or I should say standard free energy for exothermic reaction?
Yes, sir.
Negative, positive, or zero?
Yes, sir. Can I use paper and pen?
No. For this, no.
Okay. Sorry, sir. I haven't seen it clearly. Okay, sir. Here, in the case of exothermic reaction, enthalpy is negative, obviously. And coming to the entropy, we are entropy that increases with the addition of heat. But here we are taking heat out now, sir. So entropy should be negative here. So this standard free energy delta H minus T delta S.
You said that thermodynamics is not your strong suit, and is automatically you want to come under the truck by using those terms. Why? I simply ask a Gibbs energy change, and you include enthalpy, entropy, and the moment you use entropy, after that you will just allow them to open the everything, every weapon towards you.
Yes,
You know,
sir.
entropy means anything they can ask.
Yes, sir.
With Manish sir, in which topic you had the first discussion? On which topic he asked you the first question?
It's about difference between first Sir asked about different modes of heat transfer and
Now, simple. If they want, they can include entropy with these things. They can ask you for a given temperature change, entropy will be high for conduction, for convection, or for radiation. Entropy can be used anywhere, you know.
yes,
If heat is involved, so entropy will come definitely.
yes, sir.
So why you are? Simple answer is Gibbs energy change. What Gibbs energy change signifies? Spontaneity of the process.
Reaction. Yes, sir.
If I am saying exothermic reaction, be it exothermic or endothermic or any reaction,
Yes, sir.
if it is spontaneous, so delta G has to be
Negative, sir.
negative.
Yes,
That is the answer.
yes, sir.
That is the simple answer. Now, further, if they ask, like you have included, so and we are about to conclude the session, so let me answer this also. If further they ask this type of thing, why negative, then you have to include thermodynamics in the picture, because the answer of each why you will find in thermo only. Okay.
Yes,
So first thing, exothermic reaction, enthalpy change will be negative.
yes, sir.
Why?
Due to heat released during the reactions.
Why?
Enthalpy of exit products will be greater than the enthalpy of reactants.
And we are talking about exothermic reactions.
Sorry, sir. Enthalpy of exit products will be less than the enthalpy of reactants.
Correct. So delta H will be negative.
Yes, sir.
Newton's, third law of thermodynamics, second law of thermodynamics, they help us to understand the entropy change of all the spontaneous processes are positive.
Yes, sir.
What is delta G? Delta H minus T delta S.
T delta S,
T is
yes.
positive, delta S is positive, so that second term will always be negative.
Yes, sir.
Delta H is negative, so delta G is negative.
Yes.
Then you can include. Don't use any such term which you don't want to discuss.
Okay.
You must have heard this line at many places. You should be the driver in the interview, drive the interview by your choice. Okay.
Yes.
Take the control of everything in the interview by yourself. What is the meaning? You understand that whatever you gonna speak, they will gonna ask the cross questions or follow-up questions on your answers.
Yes.
So if you want to drive the interview, then try to answer in such a manner, if possible. If you
Yes.
can control your instincts there, then use those words on which you want them to do the follow-up questions. Don't use any such word which can give you a trouble. Okay. Like entropy is one thing. If you have seen other previous interviews with some candidates, I did also ask, what is the entropy generation in CSTR? What is the entropy change in evaporator? How they will calculate the entropy generation in distillation column?
Yes.
Okay. Anyways, so I will give you my feedback and then Manish sir will continue the discussion further. Okay. So Ganesh,
Yes.
first thing I see, you mentioned many subjects. Obviously, due to time constraint, we were not allowed, or it is not possible to ask many questions. So we were not able to discuss many things from mass transfer or thermo directly. But indirectly, we did ask some of those things. I hope they will help you. And
Yes.
for the extra question, other question, you can watch the practice sessions, mock sessions of other candidates. Okay.
Yes.
So about feedback about you is, see, you have a good knowledge. Whatever discussion we had, we saw. I analyze that you are trying to answer each and everything. That's good.
Yes.
But if there is anything which you don't know, then don't waste your time in thinking. Directly say no. Like I did ask you, catalytic poisoning in nuclear reactors. You don't have any idea. You were thinking. You can simply say, sir, sorry, no, I don't have any idea. And don't try to use any fluke or something. Like in nuclear reactor, you use a statement like, sir, there is no catalyst or something.
Okay.
That's why I told you, understand why they are asking any question. If you go by the statements, basics, catalyst is not always solid particles.
Yes, sir.
Anything which improve the rate of reaction, that is catalyst.
Yes, sir.
Okay, that is one thing. So try to avoid these type of things. Don't give any vague answers. Simply say yes or no. Either 0 or 100%. There is nothing in between. Okay?
Okay.
And say one more thing. When I ask you the concepts of fluid mechanics involved in the nuclear reactors, you started giving the assumptions. First you said Reynolds number, that was fine. Then you said the streamline flow, steady flow. These are the assumptions. What will I do with the assumptions? I'm not asking you to design anything. I just asked the name of those topics.
Yes, sir.
And when you were giving the name, then you were explaining why these, why these. They are not interested to ask why. If they are interested, they will ask you. So this is the beauty of BARC and NPCIL. There is always point-to-point discussion. Okay. They are not
Okay.
interested in your story.
Okay,
Like
sir.
initially, Manish sir asked you, give us your introduction. You shared all the details, including your father's and mother's name and some details. But suppose if they ask you, what is your name? Will you say Ganeshwar Reddy or will you say my name is this, my father name is this, mother name is this?
I will only say my name itself.
That is the whole idea. So don't use any extra word. Okay.
Okay, sir.
This is one thing I saw in some question. You were trying to do that. Don't explain unnecessarily. If they want explanation, they will tell you.
Okay,
Okay.
sir.
From your side, don't give. Otherwise, it will be like you are throwing yourself under the bus.
Okay, sir.
And I don't think you want that to happen. Okay. And read this. And one good thing about you that you were having the idea about the basics of BARC and NPCIL, what they do. But why you brought a DRDO there
So,
in one of the question?
yes, sir. Basically, DRDO works in the development of weapons and weapons, sir. So I thought like
That was just funny question for time. Has nothing to do in interview. Obviously, in interview, they are not going to ask you such thing. How to design atomic bomb. Obviously, a BTech level candidate cannot answer such thing. This was that just I ask for fun, just to make you little normal, because most of the students, especially chemical engineers, are feel happy when we talk about the weapons or atomic bombs, etc. So I thought you will also
yes,
be.
yes,
But
right.
you brought DRDO. I know DRDO also just released their notification few days back. You are excited about it, but don't forget you are here. Okay. So this is one thing, that don't try to bring some unnecessary stuff. It will only cause you trouble. Okay. Try to be crystal clear, simple point to point answer. If they want any explanation, they will ask. Don't worry. Okay. And one suggestion, one thing will be, one advice. In those interviews, try to be present. Okay? Don't go any here and there, because in those interviews there will be one person. If you are going to stuck at some question or anything, so some of the person from the panel will give you some hint.
Okay.
They do this with every candidate. They want to see how much present you are, what is your level of concentration. Okay. So if you can catch those hint and answer, that is a benefit for you. Okay. So if you don't know anything, simply say no. If you are stuck, and if you are stuck or having some 99% doubt surety, then answer. But if you don't if you are not stuck, or for any question during the discussion, if you are stuck, then you can answer with those 90 or 80% surety. But don't give the first answer with 90% surety. Simply say no.
Okay.
If you have even a slight doubt in the start, because this will be the flow. Fundamental basic question, then related some mathematical application, and then advanced. That will be the flow in these two interviews. Okay. So good luck. I hope you will do good. Just avoid these things and everything will be sorted. Okay. So Manish sir.
So voice is not audible.
ओके अभी जरा चेक करो तो आ रही है क्या आवाज? हेलो.
Yes, sir.
तो गणेश सर ने सारा कुछ आपको गाइड कर दिया है कि क्या चीजें आपको करनी है, क्या चीजें नहीं करनी है स्पेशली, है ना. तो इन चीजों पर थोड़ा सा ध्यान रखना. बाद बाकी कुछ ऐड करने के लिए बचा नहीं है ना. तो सर्टेन चीजें ही होती हैं जो सर ने सारी बताई दी है आपको. राइट. तो ठीक है गणेश, है ना. और आपके इंटरव्यू के लिए ऑल दी बेस्ट. जो रिमेनिंग इंटरव्यूज हैं उनको जरूर एक बार फॉलो करके जाना. बस यही लास्ट में सजेशन रहेगा, है ना. और अच्छा करो, कॉन्फिडेंस के साथ जाओ. और ठीक है, होपफुली आपका बहुत अच्छा इंटरव्यू. ठीक है, ऑल दी बेस्ट.
और अपनी स्माइल कैरी करना पूरे इंटरव्यू में. जितना ज्यादा एनर्जेटिक आप रहोगे, उतना ज्यादा इंटरेस्टिंग आपका इंटरव्यू होगा. The more you will be show the energy, the more interesting it will become, and the more interesting it will be, they will start liking you.
Okay.
Okay, good luck.
Thank you.